There is a storm on Jupiter so big you could drop the entire Earth into it, and it would just disappear. And that storm has been raging for at least 350 years, longer than anyone watching this has been alive, longer than your great-great-grandparents, longer than some countries have existed. Now here's the crazy part. Jupiter is so massive that it basically acts like the bodyguard of the entire solar system. And if it suddenly vanished, life on Earth might be in serious trouble. Stick with me because we've got 100 incredible facts about the biggest planet in our cosmic neighborhood. And by the very last fact, I'll show you something about Jupiter that almost nobody knows, something that sounds like science fiction, but is 100% real. If you love space, hit that subscribe button so you don't miss what's coming. All right, let's blast off. Jupiter is the biggest planet in our solar system, but big doesn't really do it justice. Here's the wild part. If you took every single other planet, Mercury, Venus, Earth, Mars, Saturn, Uranus, Neptune, and mashed them all together into one giant ball, Jupiter would still be more than twice as heavy as all of them combined. Twice, think about that. It's like one player on a sports team outweighing all the others put together, with room to spare. That's why ancient astronomers named it after the king of the Roman gods. They didn't even know how massive it really was. They just saw a bright, powerful light in the sky, and somehow got the name exactly right. Jupiter isn't just a planet. It's the heavyweight champion of the whole neighborhood.
Okay, let's really picture how big Jupiter is. Imagine Jupiter is a giant hollow glass ball. How many Earths could you pour inside it? The answer is around 1,300 Earths. If our planet were a marble, Jupiter would be a beach ball. Go ahead and try to imagine 1,300 of anything, 1,300 people, 1,300 cars. It's a number that's almost too big to feel. And yet every single one of those Earths would just be empty filler inside this monster. Across its middle, Jupiter is about 89,000 miles wide. That's roughly 11 Earths lined up side by side, just to stretch across it once. So next time you look up and see that bright dot in the night sky, remember, that little point of light is over 1,000 of our worlds rolled into one. Here's something that messes with people's heads. You couldn't land a spaceship on Jupiter because there's nothing to land on. Jupiter is made almost entirely of gas, mostly hydrogen and helium, the same two ingredients that make up the sun. So if you tried to stand on Jupiter, you wouldn't hit a surface. Instead, you'd just sink deeper and deeper through thickening clouds, the pressure crushing harder and harder, the heat rising and rising, until you were squeezed out of existence long before you ever reached the center. Think of it like an ocean with no floor, except the ocean is made of clouds and gas that slowly turn to liquid the deeper you go. That's why we call it a gas giant. It's basically a failed star that never quite caught fire. And speaking of that, this one sounds like a stretch, but it's true. Jupiter is made of the same stuff as the sun, and if it had been born much bigger, our solar system might have had 2 suns. Scientists believe that to actually ignite and become a star, Jupiter would have needed to be about 80 times more massive than it is. That sounds like a lot, but in cosmic terms, it came surprisingly close to crossing that line. If it had, Earth might have orbited in a system with 2 stars in the sky, just like Tatooine in Star Wars. Instead, Jupiter never gathered enough material to spark nuclear fusion in its core, so it stayed a planet. A giant, glowing, almost star that just barely missed its shot at stardom. Honestly, lucky for us. A second sun would have made Earth a very different and probably uninhabitable place. You'd think the biggest planet would be slow and lazy, right? Wrong. Jupiter spins faster than any other planet in the solar system. One full day on Jupiter, a complete spin, takes just about 10 hours. Compare that to our 24-hour day. So this gigantic ball, 11 times wider than Earth, is whipping around so fast that its morning to night happens in less time than your average night's sleep. And because it's spinning so quickly, Jupiter actually bulges out in the middle. It's not a perfect sphere, it's slightly squashed, like a basketball someone sat on. The speed of that spin is so intense that the clouds at its equator are racing around at tens of thousands of miles per hour. Imagine the fastest race car you've ever seen. Now imagine an entire planet spinning that fast. That's Jupiter every single day. Here's a fun flip. Jupiter's days are super short, but its years are incredibly long. It takes Jupiter nearly 12 Earth years to make one full trip around the sun. Why? Because it's so far out, about 5 times farther from the sun than we are, so it has a gigantic orbit to complete, and it travels that path more slowly than we do. Think about what that means. If you were born on Jupiter, you'd only have your first birthday at age 12 in Earth years. A 60-year-old human would be just 5 Jupiter years old. Your whole childhood, all the way through middle school, would happen before Jupiter finished a single lap around the sun. So Jupiter lives life in fast forward by day and slow motion by year, two completely different clocks running on the same giant world. At the top of Jupiter's clouds, it's freezing. We're talking around minus 145 degrees Celsius, cold enough to instantly turn you into an ice sculpture. But here's the twist: the deeper you sink into Jupiter, the hotter it gets. Way down near the core, scientists estimate temperatures may reach tens of thousands of degrees, hotter than the surface of the sun. So Jupiter is like a planet of extremes stacked on top of each other, bone-chilling cold up top, blast furnace heat at the bottom. There's no single temperature for the whole planet because it changes wildly depending on how deep you are. Picture diving into a pool where the top is frozen solid but the bottom is molten lava. That's the kind of insane range we're dealing with. Jupiter doesn't pick one extreme, it does all of them at once. Most planets just soak up warmth from the sun. Jupiter, it actually glows with its own leftover heat. Here's the amazing part: Jupiter radiates more heat out into space than it receives from the sun. Roughly twice as much, in fact. So where does that extra heat come from? Scientists believe it's energy left over from when Jupiter first formed billions of years ago, plus the slow, ongoing squeeze of the planet very gradually shrinking under its own gravity. As it contracts just a tiny bit each year, that pressure releases heat, like how rubbing your hands together makes them warm. So Jupiter is basically still cooling off from its birth, glowing faintly in the infrared like a dying ember from the dawn of the solar system. It's not a star, but it's not entirely cold and dead either. It's a giant that's still quietly burning off the heat of its own creation. Jupiter is surrounded by an invisible force field so powerful it would fry you instantly. Its magnetic field is about 20,000 times stronger than Earth's, the most powerful of any planet in the solar system, and it's enormous. If you could actually see Jupiter's magnetic field glowing in the night sky from Earth, it would look bigger than the full moon, even though Jupiter is hundreds of millions of miles away. This field traps deadly radiation in giant belts around the planet, so intense that any astronaut who got too close without serious shielding would receive a lethal dose almost immediately. Even our toughest robotic spacecraft have to be carefully protected just to survive a flyby. So Jupiter isn't just big and stormy, it's wrapped in a crushing, invisible cage of magnetism and radiation. Beautiful from a distance, absolutely deadly up close. You know the northern lights here on Earth? Gorgeous, right? Well, Jupiter has auroras too, except they're hundreds of times more powerful than ours and they never fully switch off. Thanks to that monster magnetic field, glowing curtains of light dance around Jupiter's poles, shining brightly in ultraviolet light. They're so big that you could fit several Earths inside a single one of these light shows. And here's a cool bonus. Some of Jupiter's moons actually feed energy into these auroras, leaving their own glowing footprints in the light. So Jupiter is permanently crowned with two enormous electric halos at its top and bottom, a constant cosmic fireworks display that's been going on for millions of years, with no audience but our spacecraft. Honestly, it might be the most beautiful thing in the entire solar system. That's our first 10, but trust me, we're just getting warmed up. Coming up, we've got a storm older than your country, a moon with more volcanoes than anywhere else in the solar system, and an ocean that might be hiding alien life. The next 10 facts get weird in the best way. Let's keep going. When you look at Jupiter, you see those famous horizontal stripes, and they're not just for decoration. Those bands are actually massive streams of clouds moving in opposite directions. The lighter stripes are called zones, where gas is rising up and cooling. The darker stripes are called belts, where gas is sinking back down. They sit right next to each other, racing in opposite directions, which creates wild turbulence where they meet, like two rivers flowing past each other and churning at the border. The colors come from different chemicals in the clouds: ammonia, sulfur, and other compounds that paint Jupiter in creams, oranges, browns, and reds. And these stripes aren't permanent. They shift, fade, and sometimes a whole band will mysteriously vanish for a while, then come back. Jupiter is basically a giant slowly repainting itself with chemistry. No 2 years look exactly the same. The strongest hurricane ever recorded on Earth had winds around 200 miles per hour, terrifying. On Jupiter, the winds laugh at that. In those striped jet streams, winds can scream along at over 400 miles per hour. That's roughly twice as fast as our worst hurricanes, And these winds don't burn out after a few days like ours do. They blow continuously, year after year, century after century. There's no land, no mountains, no coastline to slow them down, so they just keep racing around the planet forever. Imagine a wind so strong and so endless that it never, ever stops. If you somehow stood in it, you wouldn't just be blown away, you'd be vaporized. Jupiter's atmosphere is the most violent, high-speed weather system we know of anywhere, and it's been running non-stop since long before humans existed. This is one of the strangest things in all of science. We normally think of hydrogen as a light, invisible gas, the stuff in balloons. But deep inside Jupiter, the pressure is so insanely crushing that hydrogen gets squeezed into a bizarre form called liquid metallic hydrogen. It actually behaves like a shiny, electricity-conducting metal, like a giant ocean of liquid metal sloshing around in the planet's interior. We can't easily make this stuff on Earth because we can't recreate that kind of pressure for long. But scientists believe this metallic ocean is the secret behind Jupiter's monster magnetic field. As it churns and flows, it generates electric currents that power that invisible force field we talked about. So at its heart, Jupiter hides an ocean unlike anything you've ever seen. Not water, not lava, but liquid metal made of the lightest element in the universe. Mind-bending, right? For a long time, scientists assumed Jupiter had a solid, rocky core buried deep at its center. But then NASA's Juno spacecraft arrived and studied Jupiter's gravity in incredible detail, and the data suggested something surprising. Jupiter's core might not be a neat, solid ball at all. Instead, it appears to be fuzzy or diluted, meaning the heavy core material is partly blended into the gas above it, smeared out across a huge region instead of packed tightly together. Scientists think this might have happened from a massive collision early in Jupiter's history, when another young planet may have smashed into it and mixed everything up. So the very center of Jupiter is still a bit of a mystery, a blurry, blended zone instead of a clear boundary. Even with our best technology, the biggest planet still keeps some of its deepest secrets hidden. And honestly, that's part of what makes it so fascinating. Everyone knows Saturn has rings, but did you know Jupiter has them too? Most people have no idea. Jupiter's rings are faint, thin, and made mostly of tiny dust particles, rather than the big bright chunks of ice that make Saturn's rings pop. That's why you can't spot them through a backyard telescope. They're almost invisible unless you're looking from just the right angle with the sun behind them. We didn't even confirm they existed until a spacecraft flew by in 1979 and caught them in the light. Where does all that dust come from? Scientists believe it's blasted off Jupiter's small inner moons by constant tiny meteorite impacts, creating a faint halo of debris that drifts around the planet. So Jupiter is secretly wearing a delicate set of dusty rings, a subtle, almost hidden crown that hardly anyone ever talks about. Here's a thought that might make you grateful for Jupiter. Its enormous gravity may have helped life survive on Earth. Because Jupiter is so massive, it acts like a cosmic vacuum cleaner. Its gravity grabs incoming comets and asteroids and either flings them away or swallows them up before they can reach the inner solar system. Many scientists believe Jupiter has deflected countless space rocks that might otherwise have slammed into Earth and caused mass extinctions. In 1994, we actually watched this happen. A comet called Shoemaker-Levy 9 was torn apart by Jupiter's gravity and crashed into the planet, leaving scars in its clouds bigger than Earth. Better Jupiter than us, right? So in a strange way, that giant, deadly planet way out there might be one of the reasons we're all here today. Earth's giant bodyguard standing watch. Okay, plot twist, Jupiter isn't only a protector. Scientists now think the story is more complicated. That same powerful gravity that flings space rocks away can also yank other objects out of the distant asteroid belt and slingshot them toward the inner solar system, including toward Earth. So Jupiter is kind of a double-edged sword. It blocks some threats but creates others. Researchers still debate whether Jupiter has been a net good guy or a bit of a troublemaker over the history of our solar system. The truth is probably somewhere in between. It saved us from some impacts and possibly caused others. Either way, it shows just how much influence one giant planet has over everything around it. Jupiter doesn't just sit quietly in its corner. It's constantly reshaping the paths of objects across the entire solar system, for better and for worse. You've probably seen Jupiter without even realizing it. After the Moon and the planet Venus, Jupiter is usually the third brightest natural object in the night sky. It shines as a steady, creamy white point of light, and unlike stars, it doesn't really twinkle. That's actually a handy way to spot a planet. Stars twinkle, planets shine steadily. Jupiter is so bright that you can see it with your naked eye from a city, even with light pollution around you. And here's the best part. If you grab even a cheap pair of binoculars and look at Jupiter, you can often see 4 tiny dots lined up next to it. Those are its 4 biggest moons. That's the exact same view that changed astronomy forever 400 years ago, which, funny enough, is our very next fact. Back in 1610, an Italian astronomer named Galileo Galilei pointed his homemade telescope at Jupiter, and what he saw shook the foundations of human knowledge. He spotted 4 little points of light next to the planet, and night after night, he watched them move around Jupiter. He realized these were moons orbiting another world, not Earth. Why was that such a big deal? Because back then, almost everyone believed Earth was the center of the universe, and everything revolved around us. But here was clear proof that things could orbit something other than Earth. It helped shatter that old belief and supported the idea that Earth orbits the Sun. Those 4 moons are still called the Galilean moons in his honor. So a single glance at Jupiter, 4 centuries ago, helped kick off the entire scientific revolution. Not bad for a guy with a tube and some glass lenses. Earth has 1 moon, Jupiter. Try around 95 confirmed moons, and astronomers keep discovering more all the time. As of recent counts, Jupiter holds the record neck and neck with Saturn for the most known moons of any planet. Most of them are tiny, just lumpy chunks of rock a few miles wide, probably asteroids that wandered too close and got captured by Jupiter's gravity. But a handful are absolute giants, including 4 that are big enough to be worlds in their own right. Some of these moons orbit in the wrong direction, backward compared to the others, which is a strong clue that Jupiter snatched them from space rather than forming them itself. So Jupiter isn't just a planet, it's like a mini solar system, with its own swarm of worlds circling around it. And a couple of those moons, they might be the best places to search for alien life. More on that soon. That's our first 20 in the bag: size, structure, storms, magnetism, and our first peek at those moons. Up next, we go deep on the Galilean moons, the volcano world of Io, the hidden oceans of Europa and Ganymede, and why scientists are dead serious about hunting for life out there. Earth's moon is impressive until you meet Ganymede. Ganymede is the largest moon in the entire solar system, and here's the kicker: it's actually bigger than the planet Mercury. Let that sink in. A moon that's larger than an entire planet. If Ganymede orbited the Sun on its own instead of circling Jupiter, we'd absolutely call it a planet without hesitation. Giant ball of rock and ice, about 3,270 miles across, slowly looping around Jupiter once every week or so. And it's not just big, it's complex, with light and dark regions, ancient craters, and grooved terrain carved across its surface billions of years ago. So while we casually call it a moon, Ganymede is really a world in its own right, one that dwarfs some of the official planets in our solar system. Jupiter doesn't just have moons, it has worlds. And Ganymede has a superpower no other moon can claim. Out of every moon in the solar system, Ganymede is the only one that generates its own magnetic field. Planets like Earth and Jupiter have magnetic fields, sure, but a moon doing it, that's unheard of anywhere else. Scientists believe this happens because Ganymede has a molten, churning iron core deep inside, just like a small planet. That swirling metal acts like a giant dynamo, producing magnetism. The really cool part is that Ganymede's little magnetic field sits inside Jupiter's gigantic one, creating a strange bubble within a bubble. And that magnetic field even gives Ganymede its own faint auroras, glowing lights near its poles, just like Earth's northern lights. So this single moon is basically behaving like a tiny planet, complete with a metal heart and its own light show. Nature really doesn't follow our neat little rules, does it? Ganymede has another secret hiding beneath its icy shell, a secret ocean. Scientists believe that deep under Ganymede's frozen crust lies a vast saltwater ocean, possibly holding more water than all the oceans on Earth combined. How do we know it's there if we can't see it? Clever detective work. Astronomers watched the way Ganymede's auroras wobbled, and the only thing that could explain that motion was a hidden, salty, electrically conducting ocean tucked beneath miles of ice. So picture this, a frozen moon, looking dead and gray on the outside, quietly cradling an enormous dark sea in its depths. And here's the exciting bit: wherever scientists find liquid water, they start asking the big question: could something be living in there? Ganymede might look like a barren snowball, but on the inside, it could be one of the wettest worlds we know. Now let's talk about the moon that gets scientists most excited of all, Europa. From a distance, Europa is one of the smoothest objects in the entire solar system, a brilliant white ball wrapped in a shell of ice, crisscrossed by mysterious reddish-brown cracks like the lines on a cracked eggshell. There are almost no craters on it, which is a huge clue. It means the surface is young and constantly being refreshed. Something underneath is resurfacing it, and that something is what makes Europa famous. Underneath that smooth, icy crust, scientists are confident there's a global ocean of liquid salt water. Europa might look like a frozen marble, but it could be hiding one of the most important environments in the entire solar system just below the surface. And once you hear what's in that ocean, you'll understand why everyone's so obsessed with this little moon. Here's the jaw-dropper about Europa's ocean. Scientists estimate it may contain about twice as much water as all of Earth's oceans put together. Twice. And remember, Europa is smaller than our own moon. So how does a tiny moon hold double the water of our entire planet? Because that ocean is incredibly deep, possibly 40 to 100 miles deep, compared to Earth's oceans, which average only a couple of miles. Imagine an ocean so deep it makes the Pacific look like a puddle, all of it kept liquid, even way out in the freezing cold of deep space, by heat generated inside the moon. So this modest little world is secretly one of the biggest water reservoirs in the solar system. A frozen shell on the outside and a planet-sized sea hidden within. It's like a cosmic snow globe with an entire ocean sloshing around inside. And here's why that ocean matters so much. Europa is widely considered the best place to search for alien life in our solar system. Think about what that hidden ocean has going for it. It's got liquid water, check. It likely has the right chemical ingredients for life, check. And it has a source of heat and energy from the moon's interior, check. On Earth, we've found bizarre creatures thriving in pitch-black oceans next to deep-sea volcanic vents with no sunlight at all. So scientists ask, if life can survive in those extreme conditions here, why not in Europa's dark, warm, mineral-rich sea? To be clear, we haven't found life there, not even close to proven. But the conditions might be just right. That's why Europa is at the very top of the list when humanity asks the biggest question of all, are we alone? And Europa might be making our search easier by spitting its ocean out into space. Scientists have spotted evidence of towering plumes, geyser-like jets of water vapor, erupting from cracks in Europa's icy surface, possibly shooting over 100 miles high. If those plumes are real and connected to the ocean below, it's a game changer. Why? Because instead of having to drill through miles of solid ice to reach the hidden sea, a spacecraft could simply fly through one of these plumes and sample the ocean water directly, scooping up whatever's in it as it passes. It's like the moon is handing us a free sample of its deepest secrets. That's exactly why space agencies are sending missions to Europa, to sniff those plumes and find out what's really down there. Imagine the headline if we flew through one and found the chemical fingerprints of life. Now let's swing over to a completely different kind of moon, Io, the most volcanic place in the entire solar system. While Europa is a frozen ocean world, Io is the opposite, a fiery, hellish ball covered in hundreds of active volcanoes, erupting constantly. At any given moment, multiple volcanoes are blasting lava and gas across its surface. There's so much volcanic activity that Io is completely resurfacing itself all the time, which is why it has almost no impact craters. They get buried in fresh lava before they can pile up. Io is the most geologically active world we know of anywhere. Earth has volcanoes, sure, but Io makes our planet look totally calm by comparison. It's a world that's never at peace, a glowing, sputtering, sulfur-coated furnace orbiting right next to those icy moons. Talk about extreme neighbors. So what powers all those volcanoes? The answer is a mind-bending process called tidal heating, and it's basically Jupiter squeezing Io like a stress ball. Io orbits very close to Jupiter, getting yanked hard by the giant planet's gravity and also tugged from the sides by neighboring moons. This constant push and pull flexes and bends Io's entire body over and over as it orbits. All that flexing creates friction deep inside the moon, and friction makes heat, a lot of heat. It's the same reason a paperclip gets warm if you bend it back and forth quickly. Except here, the paperclip is an entire moon, and the bending is so intense that Io's insides are partly molten. That's the engine behind all those volcanoes. So Io isn't heated by sunlight or by a hot core left from birth. It's literally being warmed by the relentless gravitational massage of Jupiter and its moons. And the result of all that heat is a moon that looks genuinely bizarre. People often say Io looks like a giant pizza. Its surface is splattered in yellows, oranges, reds, browns, and whites, all from sulfur and sulfur compounds spewed out by its endless eruptions. There are no blue oceans or white ice here, just a sickly, colorful crust that looks like someone dropped the largest, weirdest pizza in the universe. And those volcanoes don't gently ooze lava, either. Some of Io's eruptions are so powerful they shoot plumes of gas and dust as high as 250 miles above the surface, far higher than anything on Earth. From a distance, you can actually see these umbrella-shaped fountains arcing off the edge of the moon. So Io is this strange, beautiful, violent place, a pizza-colored world endlessly painting and repainting itself with fire. There's truly nothing else like it. Quick breather, but stay with me, because the next batch of facts is about to get even wilder. We've still got a moon that might be the safest place to build a human base, a storm so famous it has its own nickname, and the strange story of how Jupiter got its name. Trust me, you do not want to click away now. Let's keep rolling. Compared to fiery Io and icy Europa, the moon Callisto is the quiet old one, and it holds a record of its own. Callisto is the most heavily cratered object in the entire solar system. Its surface is absolutely peppered with impact scars, layered on top of each other from billions of years of getting smacked by space rocks. Why so many? Because unlike Io and Europa, Callisto isn't resurfacing itself. There are no volcanoes erupting, no ice constantly cracking and refreezing. Its surface is ancient and barely changed, basically a frozen snapshot of the early solar system. So every crater that's ever formed on Callisto is still sitting right there, like a face full of cosmic freckles. In a way, Callisto is a time capsule. By studying its battered surface, scientists can read the history of impacts going back billions of years. It's the moon that never moved on, preserving the past while its siblings constantly reinvent themselves. And here's something that makes Callisto surprisingly important for the future of humans in space. It might be the safest spot in the Jupiter system to actually visit. Remember Jupiter's deadly radiation? Well, Callisto orbits much farther out than Io and Europa, which means it sits mostly outside the worst of that lethal radiation. For any future astronauts exploring Jupiter's moons, that's a huge deal. Callisto could serve as a relatively safe base camp. On top of that, scientists suspect Callisto may also hide its own underground ocean, just like Europa and Ganymede. So you've got a calmer radiation environment, possible water, and a stable surface. NASA has even studied the idea of a crewed outpost on Callisto someday. So this quiet, cratered moon that nobody talks about might just become humanity's gateway to the outer solar system. The underdog moon could end up being our front door. Now here's a beautiful cosmic dance you've never heard of. 3 of Jupiter's big moons are locked in a perfect rhythm. Io, Europa, and Ganymede orbit Jupiter in what scientists call a resonance. For every 1 trip Ganymede makes around Jupiter, Europa makes exactly 2, and Io makes exactly 4. It's a flawless 1-2-4 pattern, like 3 runners on a track perfectly synced so they line up again and again in the same spots. This isn't a coincidence. Their gravity has nudged them into this locked rhythm over billions of years. And it's not just pretty, it's important. This constant tug-of-war is part of what keeps flexing Io and Europa, generating the heat that powers Io's volcanoes and keeps Europa's ocean liquid. So this elegant orbital clockwork is directly responsible for some of the most exciting features in the whole Jupiter system. The moons are essentially keeping each other alive and active through a cosmic game of tug-of-war. Let's go back in time to how all these moons got their names, because there's a juicy story there. Jupiter's moons are named after the many lovers and companions of the god Jupiter, or Zeus, his Greek counterpart. Io, Europa, Ganymede, Callisto. In the old myths, these were all figures romantically linked to the king of the gods. And since Jupiter, the planet, kept turning out to have more and more moons, astronomers needed more and more names, and let's just say Zeus gave them plenty of material to work with. The mythological Jupiter was famous for his many romances, so there was never a shortage of names to assign. It's a fun little reminder that astronomy and ancient storytelling are deeply tangled together. Every time we point a telescope at one of these moons, we're also echoing myths that people told around fires thousands of years ago. Science and legend, orbiting the same giant planet. Not all of Jupiter's moons are well behaved, though. While the four big Galilean moons orbit nicely in the same direction Jupiter spins, many of Jupiter's smaller, outer moons orbit backward, the wrong way. Scientists call this retrograde motion, and it's a big clue about where these moons came from. A moon that formed alongside Jupiter would naturally circle in the same direction as everything else. But a moon going backward, that strongly suggests it didn't form there at all. Instead, it was a passing asteroid or chunk of rock that wandered too close and got captured by Jupiter's powerful gravity, trapped into a reversed orbit. So Jupiter isn't just a planet with moons, it's also a cosmic collector, snatching wandering objects out of space and keeping them as trophies. Many of those dozens of tiny outer moons are basically captured prisoners, looping around their giant jailer in the wrong direction forever. Tucked in close to Jupiter is a strange little moon called Amalthea, and it breaks a rule you might expect. Amalthea is one of Jupiter's inner moons, small, lumpy, and shaped more like a potato than a ball. But here's the odd part. Amalthea is one of the reddest objects in the entire solar system, even redder than Mars. Scientists aren't completely sure why, though the reddish coating may come from sulfur drifting over from Io's volcanoes, slowly painting its neighbor. Even weirder, measurements suggest Amalthea is surprisingly low in density, so light in fact that it might be a loosely packed pile of rubble with empty spaces inside, rather than a solid rock. So this tiny red moon is full of mysteries, oddly colored, oddly light, and quietly orbiting deep inside Jupiter's radiation zone. It's easy to overlook next to the giant Galilean moons, but Amalthea is proof that even Jupiter's small companions have strange stories to tell. Here's something most people have never heard. Jupiter shares its entire orbit around the Sun with two giant swarms of asteroids. These are called the Trojan asteroids, and they travel along the same path as Jupiter, one swarm cruising ahead of the planet, and one trailing behind like a cosmic escort. They're trapped in special gravitational parking spots, where the pull of the Sun and Jupiter balance out perfectly, so the asteroids can sit there stably for billions of years. There are likely hundreds of thousands, maybe even millions of these Trojans, and they're thought to be ancient leftovers from the birth of the solar system, basically fossils from over 4 billion years ago. Right now, a NASA spacecraft called Lucy is on a mission to fly out and study several of these Trojans up close. They could hold clues about how the planets themselves first formed. So Jupiter doesn't travel alone, it leads a parade of ancient asteroids around the Sun. And here's a fun one to wrap up this batch. Jupiter is so far away that the sunlight reaching it is dramatically weaker than what we get here. Jupiter orbits about 5 times farther from the Sun than Earth does, and because light spreads out and fades over distance, sunlight at Jupiter is roughly 25 times weaker than the sunlight we enjoy. So if you were floating at the top of Jupiter's clouds, the Sun would look noticeably smaller and dimmer, still bright, but more like a brilliant, distant lamp than the warm Sun we know. It's like the difference between standing right next to a campfire and watching it from across a field. This is also a big challenge for spacecraft out there. With sunlight so weak, solar panels struggle to collect enough energy, which is why missions to Jupiter and beyond often need special power sources just to keep running in the gloom. That's the moons of Jupiter, from volcano world Io to the hidden oceans of Europa and Ganymede. Coming up next, we dive into the star of the show, the Great Red Spot, that monster storm bigger than Earth, plus the wild history, mythology, and surprising science behind the giant planet itself. Let's talk about the most famous storm in the solar system, Jupiter's Great Red Spot. This is a gigantic, swirling hurricane-like storm that has been raging for centuries, and it's so enormous that you could fit the entire Earth inside it with room to spare. Picture that, a single storm wider than our whole planet, spinning around and around in Jupiter's clouds. Astronomers have been watching it for at least 350 years, possibly longer, which means it's been storming since before telescopes were even common. Imagine a hurricane on Earth that never stopped, not for a week, not for a year, but for centuries. That's the Great Red Spot. It's the largest and longest-lasting storm we know of anywhere in the solar system, a permanent red eye staring out from the face of the giant planet. And the more we study it, the stranger and more impressive it becomes. So why is the Great Red Spot red? Honestly, scientists still aren't 100% sure, and that's part of the fun. The leading idea is that chemicals in Jupiter's clouds, possibly compounds containing sulfur and phosphorus, get pushed high up by the storm and are then zapped by the sun's ultraviolet light. That reaction may create the reddish-brown color we see. The exact recipe is still being worked out because we can't just scoop up a sample and test it. The storm's color even changes over time. Sometimes it's a deep brick red, other times it fades to a paler salmon shade. So the Great Red Spot isn't just a storm, it's a giant chemistry experiment playing out in the clouds, painted by sunlight and mystery ingredients. The fact that we still don't fully understand its color after centuries of watching just shows how much Jupiter still has to teach us. Here's something a little sad but fascinating. The Great Red Spot is shrinking. When astronomers first measured it carefully, the storm was wide enough to swallow 3 or 4 Earths side by side. But over the past century or so, it's been steadily getting smaller, and today it's down to about the width of a single Earth. Scientists have watched it shrink year after year, and they're not entirely sure why, or whether it will eventually disappear altogether. It's also been changing shape, becoming rounder and taller instead of the stretched-out oval it used to be. So we may actually be living in an era where one of the most iconic features in the solar system is slowly fading. Will the Great Red Spot vanish in the coming centuries? Maybe, or maybe it'll surprise us and stabilize. Either way, the fact that this ancient storm is visibly changing in our lifetimes is a powerful reminder that nothing in the cosmos stays the same forever. The Great Red Spot isn't the only storm on Jupiter, and in 2000, a kind of little brother was born right before our eyes. Several smaller white storms merged together and gradually turned red, forming a second red spot that astronomers nicknamed Red Spot Jr. It's smaller than the Great Red Spot, but still about the size of Earth, which tells you just how massive these things are. Watching it form gave scientists a rare front-row seat to how these giant storms come to life and change color. Sometimes the 2 red spots drift close to each other as they circle the planet, almost like they might collide. So Jupiter isn't a one-storm wonder. It's a world of swirling tempests where Earth-sized hurricanes can be born, merge, and transform within a human lifetime. The giant planet's weather is so powerful that storm the size of Earth is just an ordinary day up there. If you zoom in on Jupiter's poles, you find something that looks almost too perfect to be natural. Clusters of cyclones arranged in stunning geometric patterns. When the Juno spacecraft first photographed Jupiter's north and south poles, scientists were stunned. At the North Pole, 8 massive cyclones surround one central cyclone, arranged in a near-perfect octagon. At the South Pole, there's a similar arrangement with a slightly different number of storms. Each of these cyclones is enormous, many of them as wide as entire countries. And somehow, they hold their formation, swirling in this neat geometric pattern for years on end without merging or flying apart. It looks like a piece of cosmic art or a flower made of storms. Scientists are still studying exactly how these patterns stay so stable. It's one of the most beautiful and unexpected discoveries about Jupiter, proof that even after centuries of study, the giant planet can still completely surprise us. Let's go way back because Jupiter has been a superstar in human culture for thousands of years. The planet is named after Jupiter, the king of the Roman gods, the god of the sky and thunder, the ruler over all the others. The Greeks knew him as Zeus. Ancient peoples gave the planet this powerful name because it shines so brightly and moves so majestically across the sky. They couldn't have known it was actually the largest planet, yet they instinctively associated it with the most important god. Across countless cultures, Babylonian, Chinese, Indian, and more, Jupiter held special significance, often linked to kings, leadership, and good fortune. So long before anyone understood what Jupiter really was, humans looked up at that brilliant wandering light and sensed something majestic about it. The name has stuck for millennia. When you say Jupiter today, you're echoing a word and an idea that's been passed down through thousands of years of human wonder. The ancient Babylonians were watching Jupiter with astonishing care over 2,500 years ago and using surprisingly advanced math to do it. Clay tablets from ancient Babylon show that their astronomers tracked Jupiter's movement across the sky with great precision, and recent research revealed they were even using a sophisticated geometric technique to predict its position. This method was so advanced that it resembles ideas that wouldn't fully appear in Europe until well over 1,000 years later. In other words, ancient stargazers were doing something close to early calculus just to follow this one planet. Why care so much about Jupiter? Because for them, the heavens carried deep meaning, and tracking the king planet was tied to religion, calendars, and omens. It's humbling to realize that people thousands of years ago, with no telescopes, were so devoted to understanding Jupiter that they pushed the boundaries of mathematics itself just to chart its path. For most of history, people thought planets were perfect, unchanging lights, but Jupiter helped overturn that idea. When astronomers got better telescopes, they could see Jupiter's stripes, its storms, and its moons constantly shifting and moving. Here was a world that was clearly active, dynamic, and changing, not a flawless eternal orb. Watching the moon circle Jupiter and seeing features come and go in its clouds helped convince scientists that the heavens followed natural laws we could study and predict, not divine perfection beyond understanding. In this way, Jupiter played a quiet but important role in the birth of modern science. It was a real, churning, evolving world that humans could observe night after night. The giant planet didn't just sit prettily in the sky. It actively challenged old beliefs and invited people to ask how and why. Jupiter helped teach humanity that the universe is knowable. Jupiter doesn't just live in ancient mythology, it's woven into our everyday lives in ways you might not notice. The word jovial, meaning cheerful and good-humored, comes from Jupiter. In old astrology, people born under Jupiter's influence were thought to be happy and generous, so jovial literally means Jupiter-like. Even the name Thursday traces back to Jupiter in a roundabout way in Latin-based languages. The day is named directly after him, like Judy in French and Giovdi in Italian. So a piece of Jupiter is hiding in your calendar and your vocabulary right now. Every Thursday, in a sense, is Jupiter's day. It's a lovely reminder that this distant giant planet isn't just a far-off ball of gas. It's been part of human language, belief, and daily rhythm for thousands of years. Jupiter shaped not only the solar system, but bits of how we talk and how we mark time. Quick reset and stay with me because we're heading into the really surprising stuff now. Coming up, we've got the spacecraft that gave their lives to study Jupiter, the way the giant planet makes the sun itself wobble, and brand new missions launching right now to hunt for alien oceans. We've covered the famous storm and the ancient history. Now let's get into the truly mind-bending facts. Let's keep going. Deep inside Jupiter, conditions get so extreme that scientists believe it might actually rain diamonds. Here's the idea. Powerful lightning storms in the upper atmosphere can turn methane gas into soot, which is basically carbon. As that carbon falls deeper into the planet, the increasing pressure and heat may squeeze it, first into graphite, the stuff in pencils, and then deeper still into solid diamonds. These diamonds could then drift down through the planet like glittering hailstones. To be clear, this is still a theory based on what we know about carbon under extreme pressure, and no one has directly seen it. But the science behind it is solid enough that researchers take it seriously, and it may happen on Saturn too. So somewhere deep inside Jupiter, there could be a slow, sparkling rain of diamonds falling through the dark. It's one of the most magical-sounding ideas in all of planetary science, and it just might be true. Jupiter has lightning, but it's nothing like the gentle flashes we see during an Earth storm. Spacecraft have detected powerful lightning bolts crackling through Jupiter's clouds, and some of them are far more energetic than anything on our planet. For a long time, scientists thought Jupiter's lightning mostly clustered near its equator, like ours often does in the tropics. But the Juno mission discovered that Jupiter's lightning actually happens more toward its poles, which surprised everyone and revealed that the planet's weather works differently than we assumed. Imagine giant flashes of lightning illuminating swirling clouds the size of continents, in a storm system that dwarfs anything Earth has ever produced. There may even be a strange kind of mushball, hail, slushy balls of ammonia and water tied to these storms. So Jupiter's skies aren't just windy and colorful, they're electric, crackling with some of the most powerful lightning in the solar system. Here's a discovery that genuinely surprised scientists. There's a lot of water hidden in Jupiter's atmosphere. For a long time, researchers weren't sure how much water Jupiter actually held, and it's a big deal because water content gives clues about how and where the planet formed. When the Juno spacecraft measured the abundance of water deep in Jupiter's equatorial atmosphere, it found more than many models predicted. Now, this isn't water you could swim in, It's water vapor and molecules mixed into the deep clouds under crushing conditions. But knowing it's there, and how much, helps scientists piece together Jupiter's origin story, including where in the early solar system it gathered its building blocks. So even though Jupiter is famous as a ball of hydrogen and helium, tucked inside those clouds is a meaningful amount of good old water. It's another reminder that water, the key ingredient for life as we know it, turns up in the strangest places. Remember the Great Red Spot? Well, here's something the Juno spacecraft revealed that nobody expected. That storm has incredibly deep roots. We used to think of the Great Red Spot as a relatively shallow feature, just swirling at the cloud tops. But when Juno peered beneath the surface, it found that the storm plunges down a remarkable distance into the planet, hundreds of kilometers deep, far deeper than Earth's oceans. So the Great Red Spot isn't just a wide storm. It's a towering, three-dimensional column of churning gas extending way down into Jupiter's atmosphere. Picture a hurricane that's not only wider than Earth, but also reaches deeper than our deepest ocean trench. That's a staggering amount of swirling material, all locked into one vortex that's been spinning for centuries. It helps explain why the storm is so stable and long-lasting. It's anchored deep inside the planet, not just floating on top. The first time humanity ever got a close-up look at Jupiter was in 1973, when a little spacecraft called Pioneer 10 became the first to fly past the giant planet. Before that, everything we knew about Jupiter came from peering through telescopes here on Earth. Pioneer 10 changed all that. It bravely flew through Jupiter's intense radiation, which actually damaged some of its instruments, and sent back the first up-close photos of the giant world and its swirling clouds. It was a true pioneer, exactly as the name promised, scouting a part of the solar system no machine had ever visited. And here's a poetic touch. Pioneer 10 carried a famous golden plaque, a message showing where Earth is and what humans look like, in case it's ever found by another civilization. It's now drifting silently in deep space, far beyond the planets. So our very first hello to Jupiter was also one of humanity's first attempts to say hello to the entire galaxy. A few years later, in 1979, the twin Voyager spacecraft flew past Jupiter and absolutely transformed what we knew. These two probes captured stunning detailed images and made discoveries that stunned scientists. It was Voyager that revealed Io's erupting volcanoes for the first time, the moment we realized Io was a living, volcanic world. The Voyagers also confirmed that Jupiter has those faint rings we talked about earlier, which nobody had spotted before. They captured the swirling chaos of the Great Red Spot in incredible detail, and gave us our first real look at the four big moons as distinct, fascinating worlds. The Voyagers were just passing through on their grand tour of the outer planets, but in a matter of days they rewrote the textbooks on Jupiter. And the best part, both Voyager spacecraft are still traveling today, now beyond the edge of our solar system, the farthest human-made objects in existence, still faintly phoning home. Then came the first spacecraft to actually stay, the Galileo orbiter, fittingly named after the man who discovered Jupiter's moons. Galileo arrived in 1995 and spent about 8 years orbiting Jupiter, studying the planet and its moons in incredible depth. Instead of just zooming past like the earlier probes, Galileo settled in and looped around the giant world again and again, getting close-up views of Io, Europa, Ganymede, and Callisto over and over. It was Galileo that gathered some of the strongest evidence for that hidden ocean beneath Europa's icy shell, one of the most exciting findings in the search for life. It watched volcanoes erupt on Io and mapped the moons in detail no flyby ever could. By living alongside Jupiter for years, Galileo turned the giant planet from a place we'd glimpsed into a place we truly began to understand. It was patient, long-term science at its finest, hundreds of millions of miles from home. And Galileo did something almost no one expects. It dropped a probe straight into Jupiter's atmosphere on a one-way mission. As Galileo arrived, it released a small probe that plunged directly into the clouds, parachuting down into the giant planet. As it fell, it radioed back precious data about Jupiter's atmosphere, the temperatures, the pressures, the winds, the chemistry, measuring the planet from the inside for the very first time. But conditions got brutal fast. The probe survived for only about an hour before the crushing pressure and searing heat destroyed it, exactly as expected. In that brief time, it sent back information we could never have gotten any other way. Think about the courage built into that little machine, falling knowingly into the most hostile atmosphere in the solar system. transmitting everything it could write up until it was crushed. It was a sacrifice for science, and the data it gathered in its final hour taught us things about Jupiter we still rely on today. Here's a noble ending you might not know about. The Galileo spacecraft was deliberately crashed into Jupiter on purpose. After years of faithful service, Galileo was running low on fuel, and mission scientists faced a problem. They were worried that if they lost control, the spacecraft might one day accidentally crash into Europa and possibly contaminate that pristine ocean moon with hardy microbes from Earth. That could ruin any future search for native life there. So to protect Europa, they made the hard call to steer Galileo straight into Jupiter itself, destroying it in the giant planet's atmosphere in 2003. It was a respectful, responsible farewell, sacrificing the spacecraft to keep a possible alien habitat clean and untouched. There's something genuinely moving about that decision, humanity caring enough about a distant moon's potential life to deliberately end one of its own machines. Galileo went out as a guardian of the very worlds it spent years studying. Right now, as you watch this, a spacecraft called Juno is orbiting Jupiter and sending back some of the most spectacular images and data we've ever had. Juno arrived in 2016 and has been diving around the giant planet ever since, peering deeper into Jupiter than anything before it. It's Juno that revealed those geometric clusters of cyclones at the poles, mapped Jupiter's gravity to hint at the fuzzy core, and captured breathtaking close-up photos of the swirling clouds, images so beautiful they look like abstract paintings. Juno studies Jupiter's magnetic field, its deep atmosphere, and its inner structure, slowly peeling back the layers of the giant secrets. So everything we've talked about, the fuzzy core, the polar cyclones, the depth of the storms, a lot of that knowledge is fresh, gathered in just the last several years by this one hardworking spacecraft. We are genuinely living through a golden age of Jupiter discovery right now. Quick reset, and you're going to want to stay for these last facts because this is where it gets really cosmic. Coming up, how Jupiter makes the sun itself wobble, how it may have flung an entire planet out of our solar system, and the strangest, least known fact of all, saved for the very end. The biggest surprises are still ahead. Let's finish strong. And here's something remarkable about Juno. It runs entirely on solar power, making it the most distant solar-powered spacecraft in history. That's a huge engineering feat because remember, out at Jupiter, sunlight is about 25 times weaker than it is here on Earth. To capture enough of that faint light, Juno is equipped with 3 enormous solar panels, each one about the size of a big truck, stretching out like giant wings. Even with all that, the panels collect only a modest amount of power compared to what they'd gather near Earth. Most previous missions to Jupiter and beyond used nuclear power sources instead, precisely because sunlight gets so weak out there. But Juno proved you can run a major mission to the giant planet on sunlight alone, as long as your solar wings are big enough. It's a triumph of clever design, squeezing every last drop of energy out of a dim, distant sun. But orbiting Jupiter is incredibly dangerous, thanks to that lethal radiation, so Juno survives with a clever trick. Instead of circling at a steady distance, Juno flies in a stretched-out, looping orbit that threads through a relatively safe gap, diving close over the poles and skimming just above the cloud tops before swinging far back out again. This path lets it dodge the worst of Jupiter's deadly radiation belts, which sit around the planet's equator. On top of that, Juno's most sensitive electronics are tucked inside a thick titanium vault, basically an armored radiation shield, to protect them from getting fried. Even with all these precautions, the radiation slowly degrades the spacecraft over time. So every single close pass is a carefully calculated dance, threading the needle between getting close enough to study Jupiter and staying alive in one of the harshest environments in the solar system. Juno is essentially a heavily armored explorer, sprinting through danger to bring back its treasure. Let's zoom out for a mind-blowing one. Jupiter's magnetic field is the single largest structure in the entire solar system, aside from the sun's own influence. Its magnetosphere, the giant bubble of magnetism surrounding the planet, is so enormous that it stretches millions of miles into space. On the side facing away from the sun, Jupiter's magnetic tail reaches so far that it extends all the way out past the orbit of Saturn. Let that sink in, a magnetic field from one planet reaching across to the neighborhood of another planet. And here's the fun part we mentioned earlier. If you could somehow see this magnetic bubble glowing in our night sky from Earth, it would appear several times larger than the full moon, despite Jupiter being hundreds of millions of miles away. So the biggest thing in the solar system, after the sun, isn't something solid at all. It's the invisible, colossal magnetic empire surrounding Jupiter. And one of Jupiter's own moons is constantly feeding that magnetic empire. Remember Io, the volcano moon? All those eruptions blast about a ton of material into space every single second. That gas gets stripped of electrons by Jupiter's environment and forms a gigantic glowing ring of electrically charged particles that encircles Jupiter, following Io's orbit. Scientists call it the Io plasma torus, basically a huge invisible donut of plasma wrapped around the planet. This material gets caught up in Jupiter's magnetic field, and some of it spirals down toward the poles, helping to power those spectacular auroras we talked about. So Io isn't just an isolated volcanic world, it's actively pumping matter into Jupiter's magnetic system, lighting up the giant planet's skies. It's a beautiful chain reaction, volcanoes on a tiny moon, feeding a glowing donut of plasma, fueling auroras on a giant planet. Everything in the Jupiter system is connected in surprising ways. Here's a fact that flips your sense of how the solar system works. Jupiter is so massive that it doesn't simply orbit the sun, it actually makes the sun wobble. In any two-object system, both objects orbit around a shared balance point called the center of mass. For the sun and most planets, that point sits deep inside the sun, so we just say the planets orbit the sun and leave it at that. Jupiter is so heavy that the balance point between it and the sun actually lies just outside the sun's surface. That means the sun and Jupiter both swing around a point in empty space, and the sun visibly wobbles because of Jupiter's pull. In a very real sense, Jupiter doesn't orbit the sun in a perfect, simple way. The two of them dance around each other. Jupiter is the only planet massive enough to do this. That's how much gravitational muscle this giant has. Many scientists believe Jupiter played a huge role in shaping the entire solar system when it was young. According to one leading idea, early in the solar system's history, Jupiter may have actually migrated, drifting inward toward the sun and then back outward again over millions of years. As this giant planet moved, its enormous gravity would have stirred up everything around it, flinging material around, clearing certain regions, and influencing where the other planets ended up. Some researchers think this migration helped sculpt the inner solar system into the arrangement we see today. To be clear, this is a theory. Scientists are still piecing together exactly how it happened, but the evidence increasingly suggests Jupiter was a major architect of our cosmic neighborhood. So Earth's very existence and location might owe something to the wanderings of the giant planet billions of years ago. Jupiter wasn't just a bystander in the solar system's formation. It may have been the boss. In fact, scientists suspect Jupiter might be the reason Mars is so small. Here's the idea. When the planets were forming, Mars should have grown into a world roughly the size of Earth or Venus, but instead it ended up surprisingly tiny, only about half Earth's width. One popular explanation points the finger at Jupiter. As Jupiter migrated through the early solar system, its powerful gravity may have swept away much of the material that Mars needed to bulk up, essentially stealing Mars's building blocks. With its food supply disrupted, Mars stayed small. This idea, sometimes part of what's called the grand tack theory, is still being studied and debated. But if it's right, then the little red planet we dream of visiting is small today because a giant planet hundreds of millions of miles away bullied it during childhood. It's a powerful reminder that in the early solar system, Jupiter's gravity touched everything, even shaping the size of distant worlds. This next one sounds wild, but scientists take it seriously. Jupiter may have helped fling an entire planet out of our solar system. Some computer models of the early solar system worked best if there was originally a fifth giant planet, one we don't see today. According to these simulations, gravitational tugs of war among the giant planets, with Jupiter as the heavyweight, could have ejected that extra world entirely, hurling it out into deep space to wander the galaxy alone as a rogue planet. If true, it means our solar system may have once had an additional giant that got kicked out during a chaotic early period, possibly with Jupiter delivering the final shove. Again, this is a theory based on models, not something we've directly observed. but it paints a dramatic picture of a young, violent solar system, with Jupiter throwing its weight around so forcefully that whole planets could be exiled. The king of the planets may have literally banished a rival. Believe it or not, Jupiter has helped us discover planets around other stars. When astronomers first started finding exoplanets, planets orbiting distant suns, the very first ones they spotted were often giant gas planets similar to Jupiter. In fact, a whole category became famous, the hot Jupiters, which are Jupiter-sized gas giants orbiting shockingly close to their stars, whipping around in just days. These giants are easier to detect because their size and mass create bigger, more noticeable effects on their parent stars. So Jupiter became a kind of template, a reference point for understanding the thousands of worlds we've now found across the galaxy. Studying our own Jupiter helps scientists make sense of these distant gas giants, and vice versa. It's pretty amazing. The giant planet in our backyard is helping us understand entire solar systems light years away. Jupiter isn't just important to us, it's a key to reading the whole universe of planets. Let's daydream for a second. Imagine standing on Europa and looking up at Jupiter. It would be one of the most jaw-dropping views a human could ever witness. From Europa's frozen surface, Jupiter would loom absolutely enormous in the sky, appearing dozens of times larger than the full moon looks to us. It would hang there, this colossal striped ball of cream and orange and red, slowly turning, with the great red spot drifting across its face. You'd see Jupiter's bands shifting, maybe catch the glow of its auroras, and watch the other moons gliding by. It would dominate the entire sky, a permanent giant overhead, never rising or setting from many spots because of the way Europa orbits. Picture standing on cracked blue ice in near-total silence, with that magnificent giant filling the heavens above you. It might be the single most spectacular natural view anywhere in the solar system, and one day maybe, human eyes will actually get to see it. But here's the brutal catch to that beautiful view. The radiation near Jupiter would kill an unprotected astronaut shockingly fast. Those moons closest to the planet, like Io and Europa, sit right inside Jupiter's deadly radiation belts. An astronaut standing on Europa's surface without heavy shielding would receive a lethal dose of radiation in a matter of days, or even less. It's one of the biggest challenges for any future human exploration of the Jupiter system, that invisible, constant downpour of high-energy particles that fries electronics and damages living cells. This is a major reason scientists eye Callisto, farther out and safer, as a more realistic spot for a future base. So as gorgeous as that giant Jupiter would look in Europa's sky, the environment there is silently lethal. Visiting Jupiter's inner moons isn't just hard because of the distance, it's hard because the giant planet bathes its closest companions in an invisible storm of radiation. Good news, right now brand new missions are heading to Jupiter to explore those ocean moons. NASA recently launched a spacecraft called Europa Clipper, specifically designed to study Europa and its hidden ocean in detail. Instead of orbiting Europa directly, where the radiation would destroy it too quickly, Clipper will make dozens of daring flybys, swooping past again and again to map the moon, study its icy shell, and figure out whether that buried ocean could support life. It's loaded with cameras and instruments to sniff out the chemistry of those possible plumes and peer beneath the ice. This is one of the most exciting missions in modern space exploration because it's aimed squarely at one of the best places to search for life beyond Earth. After decades of wondering about Europa's ocean, we're finally sending a dedicated explorer to take a serious look. The answers it brings back could be some of the most important in human history. And Europa Clipper isn't alone. Europe launched its own ambitious mission, too. The European Space Agency sent a spacecraft called JUICE, which stands for Jupiter Icy Moons Explorer. Its main target is Ganymede, that giant moon with its own magnetic field and hidden ocean. JUICE will study Ganymede, Callisto, and Europa, with the eventual plan of settling into orbit around Ganymede, which would make it the first spacecraft ever to orbit a moon other than our own. The journey is long, it takes years just to reach Jupiter, but once it arrives, JUICE will investigate whether these icy moons could be habitable, mapping their oceans and surfaces in unprecedented detail. So between Europa Clipper and JUICE, two major spacecraft are now on their way to the Jupiter system, both focused on the same thrilling question. Could life exist in those dark, hidden oceans? The next decade of Jupiter exploration is going to be absolutely incredible. Jupiter today is impressive, but when it was young, it was an absolute monster. Scientists believe that shortly after it formed, Jupiter was around twice as wide as it is now, and it glowed with intense heat left over from its violent birth. Back then, it would have been radiating so much warmth that it shone faintly on its own, almost like a dim, smoldering ember in the dark. Over billions of years, it slowly cooled and contracted down to the size we see today, releasing heat the whole way, which is part of why it still glows in infrared. So the Jupiter we know is actually the calmed-down, shrunken version of a far larger, hotter giant. Imagine going back in time to the early solar system and seeing Jupiter swollen to double its size, glowing red-hot in the blackness. It was less of a planet and more of a brooding, fading furnace. The giant has been quietly shrinking and dimming ever since. Jupiter has quietly become humanity's favorite cosmic slingshot. Because the planet is so massive, spacecraft can use its enormous gravity to get a speed boost, a clever trick called a gravity assist. As a probe swings past Jupiter at just the right angle, the giant's gravity flings it forward, dramatically increasing its speed without using any fuel. It's like a skateboarder grabbing onto a passing truck to get launched ahead. Missions like Voyager, Cassini on its way to Saturn, and New Horizons on its way to Pluto all use Jupiter this way, stealing a tiny bit of the planet's orbital energy to hurl themselves deeper into the solar system. Without these free boosts, many of our greatest missions would have taken far longer or been impossible with the rockets we had. So Jupiter isn't just a destination, it's a launch pad, a gravitational catapult that has flung our spacecraft toward the farthest corners of the solar system. The giant planet gives our explorers a helping push. Here's a poetic way to think about Jupiter's insides. It contains the largest ocean in the entire solar system, but it's not made of water. Deep inside the planet, where pressures are unimaginable, hydrogen is squeezed into that liquid metallic form we talked about earlier. And that layer is so vast, wrapping around the planet's core and stretching for tens of thousands of miles, that it amounts to the biggest ocean anywhere we know of. An ocean of liquid metal, far larger than all of Earth's seas combined, hidden beneath Jupiter's clouds. You couldn't sail on it or swim in it. It's a crushing, superheated sea of electrically charged liquid metal, churning in the dark. But in sheer scale, nothing else in the solar system comes close. So when someone asks where the largest ocean in the solar system is, the surprising answer isn't on a watery moon or a blue planet. It's buried deep inside the giant ball of gas we call Jupiter. We talked about Jupiter's faint rings earlier, but here's the charming detail of where they come from. Jupiter's moons are basically shedding to make them. The outermost, wispiest rings are called the gossamer rings, and they're made from fine dust knocked off two small moons, Amalthea and Thebe. As tiny meteorites constantly pepper these little moons, they kick up dust that drifts away and spreads into faint rings tracing the moon's orbits. So Jupiter's rings aren't ancient leftovers from the planet's birth, they're actively being resupplied, right now, by debris chipped off its own moons. It's a continuous, gentle process. Little moons getting sandblasted by space, slowly feeding delicate halos of dust around the giant planet. That's why the rings are so faint and thin compared to Saturn's icy showpiece. Jupiter's rings are subtle, dusty, and self-renewing, a quiet, almost secret feature created by the slow erosion of its smallest companions. Here's something amazing about Jupiter. Backyard astronomers have actually caught space rocks slamming into it. Because so many amateur stargazers point their telescopes at Jupiter, every so often someone captures a sudden bright flash on the planet, the explosive moment an asteroid or comet smashes into Jupiter's atmosphere. It's happened multiple times in recent years, with hobbyists recording these brief fireballs and alerting professional scientists. This matters because it shows just how often Jupiter is getting hit, soaking up impacts that might otherwise threaten the inner solar system, that cosmic bodyguard role in action. And it's a beautiful example of regular people contributing to real science. You don't need to be NASA to catch a planetary collision. You just need patience, a decent telescope, and a bit of luck. So somewhere out there, an amateur astronomer in their backyard might be the first human to witness a giant impact on the largest planet in the solar system. This one is genuinely strange. One of Jupiter's famous stripes once disappeared completely. Around 2009 and 2010, astronomers noticed that one of Jupiter's prominent dark belts, the South Equatorial Belt, had faded away and basically vanished, leaving that part of the planet looking unusually blank. For a while, Jupiter looked noticeably different, missing one of its signature stripes. Then, just as mysteriously, the belt came roaring back, with bright storms erupting as it returned. What happened? Scientists think higher. Lighter-colored ammonia clouds temporarily formed over the belt, hiding the darker clouds beneath before clearing away again. So Jupiter's appearance literally changed before our eyes, then changed back. It's a powerful reminder that the giant planet is not a fixed, unchanging picture. It's a dynamic living world where entire continent-spanning features can vanish and reappear within a couple of years. Jupiter glows with auroras at its poles, but here's a mystery that puzzled scientists for years. Jupiter's powerful X-ray auroras pulse, almost like a heartbeat. Unlike Earth's gentle auroras, Jupiter blasts out high-energy X-rays from its polar regions, and these bursts flicker on and off in a regular rhythm. For a long time, nobody could explain what was driving this strange pulsing. Recently, researchers have started to crack it, linking the bursts to vibrations rippling along Jupiter's magnetic field lines, which fling charged particles crashing into the atmosphere to release X-rays. But it shows how even Jupiter's light shows are far more extreme and complex than ours. Our auroras shimmer softly. Jupiter's pound out pulsing X-rays powerful enough to be detected from Earth orbit. It's yet another way the giant planet does everything bigger and stranger. Even its beautiful polar glow is, in reality, a high-energy rhythmic phenomenon that scientists are still working hard to fully understand. Because Jupiter isn't solid, it does something planets like Earth can't. Different parts of it spin at different speeds. This is called differential rotation. On a solid planet like ours, the whole thing turns together as one rigid ball, but Jupiter is made of gas and liquid, so its equator actually rotates a bit faster than the regions near its poles. The cloud bands at the equator complete a spin in slightly less time than the bands farther north and south. It's a little like how the surface of a spinning liquid can move at different rates in different places. This difference helps drive those powerful jet streams and the sharp boundaries between the belts and zones, where fast-moving bands rub against slower ones and create swirling turbulence. So Jupiter doesn't spin as a single unit. It's more like a set of nested rings, each turning at its own pace. It's one more way that being a giant ball of gas makes Jupiter behave completely unlike the solid worlds we're used to. Let's talk about pressure, because deep inside Jupiter it reaches almost unimaginable levels. As you descend into the planet, the weight of all the gas above you piles up fast, and the pressure climbs to millions of times the air pressure we feel here at sea level on Earth. Millions of times. That's what crushes hydrogen into liquid metal and would flatten any spacecraft in an instant. To put it in perspective, the deepest part of Earth's ocean has enough pressure to implode most submarines, and the pressure deep in Jupiter is vastly, almost incomprehensibly greater than that. It's the kind of force that rearranges atoms themselves, squeezing matter into exotic states we can barely recreate in laboratories. So while Jupiter's cloud tops look soft and fluffy, the planet's interior is one of the most extreme high-pressure environments in the solar system. There's a reason no probe can survive down there for long. Jupiter's depths are a crushing abyss unlike anything humans will ever physically experience. Jupiter's magnetic field isn't just powerful, it's tilted and lopsided in a way that creates chaos. The field is tilted by about 10 degrees compared to the planet's spin axis, and it's also offset, not perfectly centered on the planet. Because of this tilt and wobble, as Jupiter rotates, its magnetic field essentially swings around like a slightly off-balance spinning top. This causes the radiation belts and auroras to shift and pulse, and makes Jupiter's magnetic environment far messier and more dynamic than a neat, centered field would be. It also means the intensity of the radiation an object experiences can change depending on where Jupiter is in its spin. Scientists have even found that Jupiter's field is surprisingly irregular, stronger in some spots and weaker in others, hinting at complicated processes deep inside that liquid metal ocean. So the giant's magnetic field isn't a tidy bar magnet. It's a tilted, offset, ever-shifting force that keeps the whole Jupiter system buzzing with energy and surprises. Even though Jupiter's clouds usually hide its depths, there are special windows that let us peek inside, called hot spots. These are relatively clear, cloud-free gaps in Jupiter's atmosphere where we can see down to deeper, warmer layers. They glow brightly in infrared light because the heat from below shines right through the opening, like looking down a clear well into the planet's interior. In fact, when the Galileo mission dropped its probe into Jupiter, it happened to fall into one of these hot spots, an unusually dry, clear region, which is part of why its measurements were a bit different from what scientists expected for the planet as a whole. These hot spots are constantly forming and shifting as Jupiter's weather churns. They're incredibly valuable because they give astronomers a rare natural opportunity to study the hidden layers of the giant planet without sending anything inside. Think of them as occasional breaks in the clouds, fleeting peepholes into the deep, mysterious heart of Jupiter. Jupiter is so important to astronomy that scientists use it as a cosmic measuring stick. When researchers discover giant planets orbiting other stars, they often describe those planets' masses in terms of Jupiter masses. For example, saying an exoplanet is 3 Jupiters heavy. Jupiter became the natural reference point because it's the biggest planet we know intimately, the gold standard for what a giant planet looks like. This unit shows up constantly in research papers and discoveries about distant worlds across the galaxy. So our Jupiter isn't just a planet in our own backyard. It's literally the ruler we use to size up giant planets light years away. Every time astronomers announce a massive new exoplanet, there's a good chance they're comparing it to the familiar giant in our own solar system. It's a quiet honor, really. Of all the worlds out there, ours is the one we measure the others against. Jupiter is the benchmark for bigness across the entire universe. Here's where Jupiter blurs the line between planet and star. Objects called brown dwarfs. Brown dwarfs are sometimes called failed stars. They're bigger than Jupiter, but not quite massive enough to ignite full nuclear fusion like a real star. They sit in the strange middle ground between the largest planets and the smallest stars. Scientists generally consider an object a brown dwarf if it's more than about 13 times the mass of Jupiter, and it becomes a true star only above roughly 80 Jupiter masses. So Jupiter sits right at the bottom of this cosmic ladder, the most planet-like rung, just below the failed stars, which themselves sit just below real stars. It really drives home that earlier fact: Jupiter is a planet that came surprisingly close to a very different destiny. Study brown dwarfs, and you're essentially studying what Jupiter might have become if it had gathered more material. The giant planet marks the boundary where planets end and the realm of stars begins. Jupiter's gravity is so dominant that it shaped one of the most famous regions in the solar system, the asteroid belt. Between Mars and Jupiter lies a vast ring of rocky debris, millions of asteroids orbiting the Sun. Scientists believe these rocks never managed to clump together into a planet, and the main culprit is Jupiter. The giant's powerful gravity constantly stirred and disrupted that region, preventing the material there from ever combining into a single world. Instead of forming a planet, the rocks were kept scattered, occasionally smashing into each other or getting flung away. So the asteroid belt is essentially a planet that never got to be born, thanks to Jupiter's overwhelming influence. Even today, Jupiter's gravity continues to sculpt the belt, creating gaps and shepherding the asteroids into certain patterns. It's another example of the giant planet acting as the master of the solar system, not just protecting and bullying other planets, but deciding whether a whole planet could even form in the first place. For all its bulk, Jupiter is noticeably out of round. It's got a serious bulge. Because it spins so incredibly fast, completing a day in about 10 hours, the planet flings its own material outward at the equator. The result is that Jupiter is measurably wider across its middle than it is from pole to pole by around 6 to 7%. That might not sound like much, but on a planet this enormous, that bulge amounts to thousands of miles of difference. If you looked at Jupiter carefully, you could actually notice that it's not a perfect circle, but a slightly squashed one, like a beach ball someone is gently sitting on. This squished shape is a direct fingerprint of its blistering rotation speed, and it's exactly what you'd expect for a fast-spinning ball of gas with no solid structure to hold it rigid. So Jupiter's shape itself tells a story. One glance at its bulging waistline reveals just how furiously fast this giant planet is spinning. Here's a thought that stretches billions of years into the future. When our sun dies, Jupiter's frozen moons might finally come alive. In about 5 billion years, the sun is expected to swell into a red giant, growing enormously and heating up the outer solar system. Scientists speculate that as this happens, the icy moons of Jupiter, like Europa and Ganymede, could warm up dramatically. Their frozen surfaces might thaw, potentially turning these moons into water worlds with oceans on the surface, at least for a while. So in the far future, long after Earth has likely been scorched, the cold, distant moons of Jupiter could briefly become some of the most temperate places in the solar system. It's a strange and beautiful idea. The same dying sun that ends life on Earth might gift the Jupiter system a fleeting era of warmth. Of course, this is speculation based on models of the sun's future, but it's a poetic reminder that the solar system is always changing, and today's frozen wastelands could be tomorrow's oases. Before we get to that final, little-known fact, here's a humbling one. No single person ever discovered Jupiter. Unlike planets such as Uranus and Neptune, which were found with telescopes and have specific discovery dates, Jupiter has been known to humans since prehistoric times. It's one of the 5 planets visible to the naked eye, so bright and obvious that our ancestors were watching it tens of thousands of years ago, long before writing, telescopes, or science existed. Every ancient civilization knew Jupiter. It has been a fixture in human skies for as long as there have been humans to look up. There's no eureka moment, no inventor, no discovery story, just an unbroken thread of people across all of history gazing at the same brilliant point of light. So when you step outside tonight and spot Jupiter, you're sharing a view with every human who has ever lived. Cave dwellers, ancient kings, sailors, and stargazers. The giant planet connects us to the entire span of human existence. And now the final fact, the one I promised at the very beginning, the thing almost nobody knows. Here it is. Jupiter sometimes captures comets and turns them into temporary moons. Most people think a planet's moons are permanent, but Jupiter's gravity is so powerful that it can grab a passing comet or asteroid and pull it into orbit for a while, sometimes for years or even decades, before the object either escapes back into space or crashes into the planet. The most famous example is Comet Shoemaker-Levy 9. Scientists realized that this comet had actually been orbiting Jupiter, not the Sun, having been captured by the giant years earlier. Jupiter's tides then ripped the comet into a string of fragments, which crashed into the planet in 1994 in a spectacular series of impacts we watched in real time. So Jupiter doesn't just have a fixed set of moons, it's constantly catching and losing temporary ones, like a giant gravitational net sweeping up wanderers from the dark. The king of the planets is always collecting new subjects and occasionally swallowing them whole. And there you have it, 100 amazing facts about Jupiter, the king of the planets. Let's quickly relive a few of the most mind-blowing ones. Remember, this is a planet so massive it's more than twice as heavy as every other planet combined, with a storm, the Great Red Spot, so enormous that the entire Earth could vanish inside it, raging non-stop for over 350 years. It hides oceans of liquid metal, may rain diamonds, makes the sun itself wobble, and might even be cradling alien life in the dark oceans of its moon Europa. And just now, you learned that Jupiter quietly captures comets as temporary moons, sometimes only to tear them apart. So here's my question for you. Out of all 100, which fact shocked you the most? Drop it in the comments. I read them, and I genuinely love seeing which ones blow people's minds. If you made it all the way to the end, you're a true space lover, so do me a favor. Hit that like button, subscribe for more deep dives into the wonders of the universe, and I'll see you in the next one. Until then, keep looking up, because the cosmos is more incredible than we could ever imagine.